Hi, good morning. Today we are going to study the physics of grade 9th. Today our chapter motion. Now we can learn this chapter the definitions of distance, displacement, speed, velocity, acceleration, the difference between distance and displacement, speed and velocity, uniform motion, non-uniform motion, graphical representation of motion, equations of motion, uniform circular motion. What is motion? Generally, motion is a term we can understand that it's a movement, moving. Yes, it's a motion. How we can say that an object is moving? A person is climbing on a wall for the painting. Girl is walking on the road. Car is running on the road. How we know that these three objects are moving? Of course, while seeing we can understand it's moving. But in physics, assumptions are not applicable. We need to prove it how the person is moving. According to a roof, a person is changing a place. According to a tree, girl is changing a place. According to a point on the road, car is moving forward direction. So we can justify that yes, objects are moving, which is changing one place to another place according to some point near to that. Yes, that point name it as a reference point. Now we can define as a motion as if an object moves from one point to another point according to a reference point is called as a motion. Yes, there are the reference points of a roof, a tree, or at some point on the road. These three are the reference points. Clear? Can we go ahead? Now, let's learn more in details. You can see that now a train is moving along through the signal pole. Signal pole is a reference point. Train is moving forward direction. That's right. Train is under motion according to a reference point of signal. Yes? Clearly we can understand what is motion now. An object changed the place according to a reference point. Clear? Now, simple example. Every student is coming to the school from their houses. From the house you are coming to school, house is a reference point. School is the destination. A person is changed a place from house to school. House is a reference point. Clear? Now, rest. What is rest? I'm at rest. I'm teaching a class. You are at rest. You are listening a class. Clear? Now, motion, moment. If I'm changing my place, I'm under moment. If you are changing the place according to your surroundings, you are under moment. Now, what is relative motion? Once you can see, a person is sitting inside of a chair car in a train. The train is going forward direction. Passenger also going forward direction. Next to the train, there are the railway station, track, another passengers who are all standing on the railway station. They're going backward direction. What we are observing in a general scenario. Yes, they are going backward direction. We are moving forward direction. After the railway station, once you can see a long way of a mountain or the trees, it's lightly coming, looks like coming forward to you, towards to your direction, if it is far distance. Clear? This is called as a relative motion. Now we can observe how that rest and motion are relative terms. Passengers are sitting in a train. You can see the passengers. These passengers are at rest. Yes, train is moving. According to each other, both are at rest. Who are all standing outside of the station? Who are all standing outside of the station? According to them, everyone is moving. Yes. Once you compare inside of the train, a person is at rest. While compared to outside of the train, all are moving. So, at the same case, a person is at rest. At the same time, he is under motion. Clear? Now, you are at rest, I am at rest, we are on the earth. Somebody observe from the sun or the moon. Earth is revolving around the sun. Moon is revolving around the earth. So if anyone observes from there, we are under movement. At the same time, at the same position, a person is at rest as well as motion. Clear? The earth appears to be at rest with respect to us, but it is revolving around the sun at 30 kilometers per second. Now we can understand that everything around us is at rest and motion in the same time. Yes? Of course, yes. Now, there is a question. How that rest and motion are relative terms? There are the chances to ask 3 marks question. 3 marks question ABCD. In that they may ask the chances. Fine. Now, example how to write it. A person sitting inside of the bus is both at rest and in the motion at the same time if co-passengers are seeing from outside of other people observe from the outside. Yes, according to co-passengers, they are at rest. According to outside of the tree or any bus stop or something, they are under the motion. Clear? Motion is always relative. A body can be at rest. A body can be a state of rest and in motion simultaneously at the same time with respect to two different bodies. Now, have you ever experienced that while you are sitting in a bus, tree outside the bus appears to be the state of motion while the person next to you appears to be at rest? Of course. While going in a bus, outside of the tree, it looks like it's a movement, but inside of the passenger, he is at rest. As well as train also the same condition. Now you see, have you ever experienced that the train in which you are sitting appears to move while it is at rest? Very important point, observe. Whenever we are at rest in the train, we are sitting in a train. When we can feel that a train is moving? Generally, while we're going in a train, if the train stop at a railway station, you are at rest, another train is coming opposite to you. On that case, once you can observe, you are feeling that you are moving. Clear? This is also relative motion. You are at rest. Frank, you are at rest. Other train is coming opposite to you. It looks like we are moving. I guess you felt this. This is also the relative motion. Now, we can study about motion in a straight line. What is straight line? Straight line means generally we can say straight line. Another meaning, without changing a direction. Without changing a direction, if object moves, that is called as a straight line motion. Direction should not change. The concept here, direction should not change. Then the type of motion is called as straight line motion. In straight line motion, you can observe a person at point O. A person at point O, he started with 0 meters. He reached to 5 meters, 10 meters, 15, 20, 25, 30. He's going in a straight line. He is not changing any direction. Clear? Now, you can see that an object started from O. It came to point A, 60 kilometers. This is the scale. Yes, on this scale, an object started at point O at 0 kilometers. It reached to point A, 60 kilometers. At the same path, it reached to point B, 35 point over here. It reached to point C, that is 25. Clear? Now, what is the total distance traveled by an object? You can see an object at point O, 0 kilometers. It reached to point A, 60 kilometers. Point B, 35 came back. Point C, 25. Now, what is the total distance? 0 to A, that is 60. Plus A to B, how much? 5 plus 5 plus 5 plus 5 plus 5. Don't add it 60 plus 35. It's wrong. A to the same straight line he came back. So 5, 10, 15, 20, 25. So 25 kilometers he traveled. Then the next 10 kilometers, because 5 plus 5, 10 kilometers. So totally how many kilometers? 60 plus 25 plus 10, which is 95 kilometers he traveled the distance. Fine. Now we can study what is distance. Yes, what is distance and how it works. Now, a car which is started from here, which is reached to here. Starting point, which is reaching to the ending point. This is the way the path is traveling. Clear? An object is starting from point A. Object is traveling from point A. This is the path. Yes, this is the path. Then it reached to point B. So, an example, the road was blocked over here. How the car can go? It can go in another path. Maybe this is the way. Some another path, whatever it is. This road also blocked. What we can do? It can choose some another path. Finally, we need to observe from point A to point B, we can travel in n number of ways. If one way close, we can choose for another way. Yes. Say an example, this actual line the car is going, this is 5 kilometers. If you travel in another way, is it will be exactly 5 kilometers? No. Even though point A, point B is constant. Whenever you are changing the path, of course, kilometers will be changed. It may be plus or minus 5. Yes. Directly you gone by helicopter. Again, it never be 5 kilometers. The different kilometers will come. So what is kilometer? What we are expressing now? It's the units of distance. Now, how we can define a distance? Simple example, the students are coming from your house to school, approximately 3 kilometers. Yes, 3 kilometers you are coming in a particular path. Now, you changed the path. Again, it may not be 3 kilometers, maybe plus or minus 3. It may be change. Yes, if direction changes, if path changes, automatically the distance also will be changed. Now, how to define the distance? Can you say that the actual path traveled by an object? The actual path traveled by an object, which path you chose? That path distance only, that's called as a path length. The path distance only, call it as a, the path length we can call it as a distance. If an object changes position from one point to another point in a particular path. Yes, the actual path traveled by an object called as a distance. Now, how to measure the distance? Can we measure with a small 15 centimeters scale from house to school? Very difficulty. Yes, we can measure a small table or a book length or very shortest length that we can measure in centimeters. For example, bit more length, our school ground. Then we can calculate these many meters. From house to school, can we calculate with a meter tape or scale or something? Very painful. What we are using for that? For example, from here to some other place, Calcutta or New Delhi or Chennai or other places. Very long distances, how to measure? In kilometers we are measuring. You are right, kilometers we are measuring. Now, how to measure the distance for long places? Which equipment we are using? That is odometer. Yes, odometer. Odometer we are observing in vehicles. There is a speedometer. The center one button is there. Numbers will be changed. Hope you are observing for the bikes, cars, or any automobiles. That we can call it as an odometer. With help of a odometer, we can able to identify, we can able to calculate the distance between the 2 points. Clear? Now coming to displacement. Displacement, a simple example. Some person asked you, where is post office? We will say, sir, there is post office. We are raising hand, we are showing casually. Why we are raising hand? If we go, this is the way, that is the minimum distance you can able to reach. Is the person can reach? No. We are sitting in a house. Where is our school? Yeah, there is our school. Can I go? This is the way? No. I need to choose my actual path. The actual path traveled by an object, call it as a distance. That is 3 kilometers from my house to my school. Whenever we are raising hand, which means this is the minimum distance we can able to travel. If you go, this is the way, this is the minimum distance we can able to travel. That is called it as a displacement. Clear? Now the displacement definition we will discuss now. The minimum distance by the object. The minimum distance traveled by the object, call it as a displacement. Rat need bread. It has to path. This is the direction. This is the direction the rat has to move to eat the bread. Actual path traveled by a rat, call it as a distance. From starting point to ending point, this is the directional path. This is called it as a displacement. Displacement also we can measure in centimeters, meters, and kilometers. Understood? It's clear? Fine. Can we move forward? All right. Yes. Now we can see some of the other points. Yes. In detail we can study. For example, this is a point A, an object start, and it reached to point B. This is 5 kilometers. Point B to point C, this is 7 kilometers. Point C to point D, this is 15 kilometers. Sorry, point D, 15 kilometers. Again, an object came from point D to point E, 5 kilometers. Now, what is distance and what is displacement? What is distance and what is displacement? Distance is equal to the total length covered by an object, the actual path traveled by an object, A to B, B to C, C to D, and D to E, right? A to B, 5 kilometers, plus B to C, 7 kilometers, plus C to D, 15 kilometers, plus D to E, 5 kilometers. Totally how much? 5 plus 5, 10, 10 plus 15, 25, 25 plus 7, 32. So 32 kilometers is the distance traveled by an object. But what is displacement? Starting point to ending point. This is starting point and E is the ending point. Between this distance, we can call it as displacement. Now, always remember, starting point to ending point is the displacement. Now, what is the displacement length now? A to B, 5 kilometers, plus B to C, 7 kilometers, plus C to E, we have to calculate. C to D, 15, D to E, 5. So, long length minus short length, the remaining this is 10 kilometers, C to E. So, plus 10 kilometers. Now, what is the total displacement? 12 plus 10, 22 kilometers. Distance is 32 kilometers. Displacement is 22 kilometers. Always distance will give the lesser value because the minimum distance traveled by an object. That's what we are raising the hand we are showing. Clear? Next. Another distance and displacement we can calculate. So an example, an object at point A, it travel up to point B 4 kilometers. Then perpendicularly it traveled point B to point C. This is 3 kilometers. Now, what is the distance and displacement? Distance means actual path traveled by an object, that is 4 plus 3 is equal to 7 kilometers is the distance. Yes. What is the displacement? How to calculate the displacement now? Starting point to ending point. So this is the way, the path covered. Now how to calculate this? Can we remember our maths teacher? It looks like right angle triangle. There is a Pythagoras theorem. Yes, as per the Pythagoras theorem, this is hypotenuse. Hypotenuse square is equal to side square plus side square, which is AB square plus BC square. So AC square is equal to AB square means 4 square 16 plus BC square 3 square 9, which is 25 kilometers. Now AC is equal to square root of 25, which is 5 kilometers. Yes, 5 kilometers. So AC distance is a displacement, that is 5 kilometers is the displacement. Now we can see another model how to calculate distance and displacement. An object at point A, it started, it's made a circle, again reached to point A. The circle, whenever I said, its radius r. Fine, its radius r. Now what is the distance and displacement? Distance means the actual path covered by an object, which is the circumference of a circle. What is the circumference of a circle? 2 pi r. 2 pi r is the distance. What is displacement? What is displacement? Starting point and ending point. The difference between starting point and ending point. In this situation, starting point and ending point is 0. Minimum distance is 0. So the displacement is 0. If an object starts from the same place, ends to the same place, then the displacement is 0. Clear? Now, another type of question. An object started from point A. It made as a semicircle. It reached to point B with radius r. Now, what is the distance and displacement? If it is total circle, distance is 2 pi r. If it is semicircle, the distance is 2 pi r by 2, which is pi r. Now, what is the displacement? What is the displacement? A to B directly, starting point and ending point, which is r plus r, 2r. Distance is pi r, displacement is 2r. Got the point? So this is the way we can understand what is distance and displacement. Clear? Can we go forward? What is the difference between distance and displacement? The total length of a path covered by a body, irrespective of the direction in which the body travels. Distance is a scalar quantity. Yes, only magnitude and no direction. Distance we can able to calculate, but there is no direction. It can choose the path direction, whatever. Yes, it's always non-negative, which means positive. Distance value is always positive. Displacement. The minimum distance traveled by an object called as a displacement. It's a vector quantity because we are raising hand and showing there's a particular direction and there's a particular value. So it's a vector quantity. Scalar and vector are new words to you. What is a scalar and vector we can discuss? Say an example. What is time now? Time probably you can say that 11 a.m. 11 a.m. Which direction? There's no direction. We can able to measure the time, but there's no direction. So time is a scalar quantity. Yes. What is your weight? Maybe 30 kg. Which direction? Downwards direction, because gravitational pull on you. That's the reason we can able to calculate. Weight is a vector quantity. Clear? What's your age? Maybe 15 years. Which direction? There is no direction. Of course, age is not a physical parameter. For your understanding, I'm saying. You can say the distance. The distance we can able to measure. Some physical parameters we can able to measure, but there is no particular direction. Displacement, we can able to Direction also we can say that this is the particular direction. Weight is a particular direction. Time is no direction. Yes. So this is called as a scalar and vector. Now, displacement can be positive, can be negative, can be zero. When it is the displacement is positive, when the displacement is positive, we can discuss. An object started from here, it reached here to point B in a straight line. Distance is, say an example, 5 kilometers. Here in this case, distance is equal to displacement. If an object travels in a straight line, the actual path traveled by an object 5 kilometers. The minimum distance between A and B 5 kilometers. If it is in a straight line, distance is equal to displacement. In this case, this displacement is a positive. Clear? Now, when it is negative, you know there are some push buttons, push switches, motor switches. You are applying the force. You are giving the force in the positive direction, but the button is coming opposite direction while switch off condition. Motor pump will switch on and switch off. While switch on, we will press the button, applying the force direction object is moving, distance, displacement, whatever. Again, if you move, it will comes back as a switch off, negative direction. In this case, displacement is negative. When it is zero, where the object started, if it is ended over there, then that will be zero condition. Got the point? Yes. Next. Hope you understood what is distance and displacement. Can we discuss what we understood? All right. Now, you can see here, an object travels 4 kilometers in east direction and turns and travels 3 kilometers in south direction. Calculate the displacement. As you know that the minimum distance traveled by an object, call it as a displacement. There are the numbers over here. 3 kilometers, 5 kilometers, 2 kilometers, 4 kilometers. Some children, they may think the minimum distance traveled by an object may be 4 kilometers and 3 kilometers. 3 kilometers is a minimum number, so 3 kilometers they may choose. Some people, the minimum value 2 kilometers is there, they may choose that. It's not the right way. We need to understand the question properly. An object travels 4 kilometers in east direction, then travels 3 kilometers. In this type of question, as a roughly noted down what is east-west. For example, this is east, west, this is north, and this is south for your observation. Now, draw with a diagram or the graph or something along to the question. An object travels 4 kilometers in east direction. This is 4 kilometers from point A to point B, 4 kilometers. Then turns travel south direction, east here, south downwards, which means this is downwards 3 kilometers. Now they're asking displacement. How to calculate displacement now? Starting point to ending point. This is. Got the point? Now again the hypotenuse square is equal to side square plus side square. Say an example, this is A, B, C. Now AC square is equal to AB square plus BC square. So AB square 16 plus BC square 9, so which is 25. Therefore AC is the displacement 5 kilometers. So which option can we choose? Option B. Option B. That's right. B is the right answer. Now, in this question you can see an object has moved through a distance. Can it have zero displacement? If yes, support your answer with an example. An object has moved a distance. Can it have a zero displacement? Of course, it's S. When it will be? Where you started, there only you have to end it again. You have to come back with the same position. Then obviously there is a distance, but no displacement. Clear? Simple example. Earth is moving around the sun. Where the Earth started, again it will be ends over there after 1 year. Then the displacement is 0. But the distance, circumference of a circle, 2 pi r. Distance will be there, but displacement will be 0. It's a possible way. Now, this question. A farmer moves along the boundary of a square field of side 10 minutes in 40 seconds. What will be the magnitude of the displacement of the farmer at the end of 2 minutes 20 seconds from his initial position? This is the most important question. A farmer moves along a boundary of a square field of side 10 meters. Draw a square field, point A, B, C, and D. Each side is 10 meters. AB 10 meters, BC 10 meters, CD 10 meters, and DA 10 meters. Each side 10 meters. Now, this farmer, in 40 seconds he covered. Say an example, farmer started from point A. It reached to again point A in 40 seconds. 40 seconds, he made it as a one round. Now the question is, what will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds? 2 minutes 20 seconds. How many seconds? 2 minutes. 2 into 60, 120 seconds. Plus 20 seconds. Totally 140 seconds. Now, one round 40 seconds. 140 seconds, how many rounds? Second round, next 40 seconds. Third round, next 40 seconds. Totally how many seconds? 40 plus 40, 80. 80 plus 40, 120. So still how many seconds are remaining? 20 seconds are remaining. One round 40 seconds. 20 seconds where the farmer can reach? At point C he can reach. Yes, right? Now, first round, second round, third round, 3 rounds, 120 seconds. So 3.5 rounds after he is reaching to point C. Now we can able to calculate the starting point to ending point, the displacement. We can redraw the diagram. This is the way. Now AC length we have to calculate. Yes, this is the displacement what they're asking. 3 rounds completed. The last round 20 seconds only. So he reached in half of distance, that is at point C. So 10, 10. Now what about the AC length? Again Pythagoras theorem. AC square is equal to AB square plus BC square. AB square how much? 100 plus BC square how much? 100, which is 200. AC square is equal to 200. AC is equal to square root of 200. Yes, square root of 200, still you can write square root of 2 into 100. So can you do that 10 into root 2? Yes, which option you can select now? Very good. 10 root 2 is the answer. Okay? 10 root 2. So this is the procedure. Fine. Each and every 20 seconds how it will be. Now, which of the following is true for a displacement? It cannot be 0. Is it? Displacement cannot be 0. Yes, it can be 0. It's a false statement. Its magnitude is greater than the distance traveled by the object. Is the displacement is greater than the distance? No. Minimum to the distance. Already we calculated the before examples. So the option is both also false statements only. First one also false, second one also false. Yes. Displacement can be 0. Displacement is always smaller than the distance. Now, we can discuss with uniform motion. What is uniform motion? You can see a car is going from point O to point A 4 meters in 2 seconds. A to B 4 meters in 2 seconds. B to C next 4 meters in 2 seconds. We understood an object is traveling equal distances in equal intervals of time. Yes, If an object travels equal distances in equal intervals of time, we can call it as uniform motion. Now, this is the graph. Graphically, on x-axis, time t, y-axis, displacement or distance, whatever, which is in a straight line. Distance is equal to displacement. That's the reason we mentioned here displacement. Now, each and every second, there is a distance also equally changing. So once you can draw the graph, this curved graph will come. Yes, this is called it as uniform motion. Next, I guess, hope you observe this what it is. Our principals will take you to identify this kind of physics in Wonderla or many places. Yes, we observed many years. Every year we can observe once. That's a technical visit or your happy visits or whatever. We are enjoying with the science. Now, once you can see that this tram, unequal distances in unequal intervals of time, sometimes very fast, while coming down very fast, while going up very slow, the different timings, the different speeds which is covering. Can we say this is non-uniform motion? Of course. Now, how to define? If an object travels unequal distances in unequal intervals of time, we can call it as non-uniform motion. Clear? If we draw the graph of distance and time graph, something curve will come. Different timings and different distances. That is called as non-uniform motion. Simple example of uniform motion. Earth is revolving around the sun, equal distances and equal intervals of time. Clock needle, equal distances and equal intervals of time. Yes, this and all uniform motion. Non-uniform motion. You can say an example, the car in a traffic. Sometimes very fast, sometimes very slow. So different timings, different distances, we can call it as a non-uniform motion. Now, our PT master making it to run. Every children is very enthusiastic to come first. Yes? What is the speed of this boy? Is he first? Let's see. Now, what is the speed? Yes? You are coming from house to school. Some people come by cycle. Some people BMTC bus. Some people by car. Some people by scooty with the parent. Whatever. If somebody asks you what is your speed, you can say that 40 kilometers, 40 kilometers per hour. Some people will say 30 kilometers per hour. Yes, different timings we are saying. Yes, now this is the house and this is the school. The distance you say that 3 kilometers. Yes, 3 kilometers you're coming by school van. Somewhere which is coming, this is the way. Actual path traveled by an object, that is 3 kilometers. Clear? How much time is taking? Say an example, 1 hour. Simple example. Take an example of 1 hour. 1 hour is taking time. Absolutely it won't take. But as per the mathematical calculation, for our convenient method, we are saying 1 hour. Or else, say an example, house to school 20 kilometers. It is taking 1 hour time. Your mindset is equal now. Maybe 1 hour it may take time. Yes? It depends on the speed, how much you are coming. We are asking a student, what is your speed? The child will think, yeah, 40 kilometers per hour. Some children will think, maybe 10 kilometers per hour. Some children will think, maybe 80 kilometers per hour, because somebody driving a car, the child saw that the meter reading, it is indicating that 80 kilometers. So the child is saying, that speed we can call it as instantaneous speed. Instantaneous speed. What is instantaneous speed? If an object at a particular place, at a particular time, the speed of a vehicle, we can call it as instantaneous speed. Okay. Now, how to calculate the speed of a person? Means, we can say that how much distance you traveled, how much time taken. Yes, distance by time, we can call it as speed. Speed is equal to distance by time, which is 20 kilometers by 1 hour. That is called as 20 kilometer per hour is the speed of a person. You may come by 80, you may come by 60, you may come by 10. That is called as instantaneous speed. But from starting point to ending point, if you calculate the total distance by total time, also the speed again. That we can call it as average speed. Average speed, nothing but speed only. The likely difference between average speed and speed is speed we are calculating from starting point to ending point. Average speed, for example, there are some points, there are some bus stops. Yes. Between these two, what is the speed? Between these two, what is the speed? Between these 2 points, what is the speed? Last 2 points, what is the speed? So if you calculate the total distance in total time, that we can call it as average speed. Got my point? Yes, clear? Can we go ahead? All right. Now, the distance covered by a body per unit time is called as a speed. Speed is equal to distance by time. So the units, distance units meters, time units seconds. So meters per second is the units of the speed. Now, what is in the non-uniform motion? What happening? Sometimes you stopped, you taken for 2 seconds of time, again you started, there is a signal, again you stop. So if you calculate this, the total distance how much, individual points, and the total time taken, we can call it as average speed. Yes, the speed units meters per second. Now we can convert alternative formulas in numericals. Speed is equal to distance by time, distance is equal to speed into time. Yes. Now, so speed is equal to distance is equal to speed into time. Time is equal to distance by speed. So this is the way we can able to alternate. Now, what is velocity? While driving a car, you can observe there's the 2 different readings. The down one reading, top one reading. Have you observed? Now, the vehicle speed 100 km per hour, but the velocity 60 km per hour. Please try to understand. So this is the odometer. This is the odometer, what you're observing here. Yes, this is the odometer. Car started. It's coming to 60, 80, 100, but the velocity is 60 something. There are the different meters, top one and down one. Yes, no? So now there's a question, is the speed and velocity are the same or in a different value? Now, the velocity, we can call it as displacement by time. Speed is equal to distance by time. Velocity is equal to displacement by time. Clear? Now, velocity is equal to displacement by time. The minimum distance traveled by an object in unit time. That is called it as a velocity. Displacement units also meters, time, seconds, meters per second, or kilometer per hour if it is in a major units. Now, velocity is a vector quantity because displacement is a vector quantity. Now, average velocity is equal to initial velocity plus final velocity by 2. What is initial velocity and what is final velocity? We can discuss. So, an example, you started a car. In the front of your house, the car speed is 0. And there are few people. You can't go suddenly 90 km per hour. You'll go very slowly. There is a main road comes, again you pick up. That time velocity we can call it as initial velocity, not from your house. It will travel some distance at a certain distance time. Again, which time the car is pick up, that velocity we can call it as average velocity. Then you are going to destination. Before reaching the destination, there is a maximum speed you are going. That velocity we can call it as final velocity. Then you will apply the brakes, car will be stopped somewhere. Now we can calculate the average velocity is initial velocity plus final velocity by 2. Got the point? Both average we are taking. So initial velocity plus final velocity by 2. That is average velocity. Velocity is equal to displacement by time. Yes, distance is equal to displacement when it is, if it is in a straight line. Both we can able to convert the formulas. Clear? Now, please note it down. This is a 3 marks question. The difference between speed and velocity. Speed. The actual path traveled by an object in unit time. Speed is equal to distance by time. Velocity, displacement by time. The minimum distance traveled by an object in unit time. Speed is a scalar quantity because distance is a scalar quantity. Velocity is a vector quantity because displacement is a vector quantity. Speed can be positive or zero. If you not travel, that is at rest. Speed is zero. Speed will be always positive because distance is positive. Velocity may be positive, negative, or zero. Yes, we can compare with the displacement. Displacement also positive, negative, and zero. So displacement by time, velocity also may be positive, negative, or zero. Now average speed is equal to average speed of a moving body never be zero. Average speed never be zero, but average velocity can be zero if it is started and ending with the same point. Now, acceleration. What is acceleration? Whenever you are accelerating a bike, we are name it as acceleration. Speed pickup is very more. Yes, the cars are coming with a very speed. The acceleration also very more. While turning, they will apply the brakes, again they'll kick the brakes. That's right. They'll apply the brakes, again click the accelerator. They'll come slow and going fast. While turning time, they should control the speed. Initial velocity to final velocity, again going for the certain speed. So this is called as acceleration. Simple experiment will do that. You are sitting on a cycle, slow, very slow you should go. Then handle you rotate it. Don't pedal it. Pedals stop it. Handles you can do that. Slightly vehicle will be moved. That's right. Now you can understand that if the direction changes each and every point, absolutely acceleration will be change. Now acceleration is equal to velocity by time because there is a initial velocity, final velocity. The change in the velocity in a unit time if it is in the non-uniform motion. Now change in the velocity we can call it as final velocity minus initial velocity. Final velocity minus initial velocity by time. Clear? Acceleration A is equal to V minus U by T. Now the units. Acceleration is equal to velocity by time. Velocity units meters per second. Time units also per second. Meters by second per second is equal to meters per second square is equal to acceleration. Got the point? Now, yes, acceleration can be positive. Acceleration can be positive while it is acting along with the direction of velocity and then taken to be a negative when it is against the direction of velocity. Yes, while coming the bikes, you can see that opposition forces are acting on them. They can't apply the brakes. If they apply the brakes, they'll stop. So they should be accelerated. Yes, there are the positive acceleration. There itself is the negative acceleration, which is opposite in time. Clear? When the acceleration of a body is a constant, it is said to be going through uniform acceleration. Clear? Now, there are few questions. Let us solve it. An object travels 16 meters in 4 seconds. Yes. And then another 16 meters in 2 seconds. What is average speed? Here the distance 16 meters and 16 meters. And the time 4 seconds plus 2 seconds. Now what is average speed? Average speed is equal to total distance by total time. Just now we discussed. Total distance by total time. So what is total distance? 16 plus 16, 32. Total time, 6. That's right. 32 by 6 approximately how much? Once you calculate, it will come as a 5.33 is the answer. Clear? 5.33. So total distance plus total time is called as average speed. Now, Usha swims in 90 meters long pool. She covers 180 meters in 1 minute by swimming from one to end, one end to another end, and back along with the same straight path. Find the average speed and average velocity of Usha. Now, in this type of question, Usha immediately draw a diagram along to the question. A Usha swims 90 meters long pool from point A to point B. This is 90 meters. And B to A she came. There's reason 180 meters. One end to another end. It came back with the same straight path. So again 90 meters she covered back. What is the average speed? Now how many seconds it taken time? How many seconds it taken time? In 1 minute they given. 1 minute, sorry, 1 minute in the sense of 60 seconds. That's right. 1 minute refers 60 seconds. Now, average speed. Average speed is equal to total distance. How much? 180 meters. How much time? 60 seconds. So once you do that, 3 meters per second is the answer. Average speed. But what is average velocity? Velocity is equal to displacement by time. Once the displacement is 0, velocity also 0. So average velocity can be 0. So you can put both options are there. You can choose any one of the option. Clear? Understood? How to solve the numerical? Yes. Now can we go ahead? Yes, 3 meters per second. Now, starting from a stationary position, Rahul pedals his bicycle to attain a velocity of 6 meters per second in 30 seconds. Then he applies the brakes such that the velocity of a bicycle becomes down to 40 meters per second in next 5 seconds. Calculate the acceleration of a bicycle, both the cases. Now you can see Rahul pedals as stationary position, means initial velocity is 0, and attains the velocity 6 meters per second. How much time? 30 seconds. Yes. Now again he apply the brakes. Whenever he apply the brakes, this is 6 meters per second consider as the initial velocity now. Once apply the brakes, what will happen? It comes to rest. So final velocity will be 0. Time will be 5 seconds. Now both the cases acceleration. First case acceleration A is equal to V minus U by T. V is equal to 6 minus 0, which is 6 by 30, which is 1 by 5. 1 by 5 in the sense of 0.2. Acceleration 0.2 meters per second square. Where is 0.2? Plus 0.2. You can see that. Here minus 0.2 is there. Wrong. Plus 0.2. Now, second one. Again, A is equal to V minus U by T. V 0, U 6 by T 5 seconds. So 6 by 5. 6 by 5. How much? Comes down to 4 meters per second, right? This is not 6, 4 meters per second. Comes down to 4 meters per second. Yes. So initial velocity here 6 meters per second, velocity 4 meters per second. So V minus U 4 minus 6 by 5, which is minus 2 by 5. Minus 2 by 5 in the sense of 0.4 meters per second square. Got the point? Here initial velocity 6 meters per second. Final velocity comes down to 4 meters per second, not at rest. 4 meters per second. So 4 minus 6 by 5 minus 2 by 5. Got the point? Now which option? Option B is the right choice. Yes? We can select as option B. Correct. Now, next, under what conditions is the magnitude of average velocity of an object equal to average speed? When the speed is equal to velocity, already we discussed if it is in a linear motion or an object which is in a straight line. Clear? What does the odometer of an automobile measures? Odometer of an automobile measures distance. Yes, right? Odometer we can measure distance. Now, speed is wrong, it's a distance. Now, when will you say a body is in a uniform acceleration or non-uniform acceleration? When the change in the velocity per unit time is constant, it goes as a uniform acceleration. When the change in the velocity per unit time varies time to time, it is non-uniform acceleration. Now, a bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. What is the acceleration? Acceleration, sorry, this is 5 hours. A bus decreases its speed 80 km per hour to 60 km per hour in 5 hours. Find the acceleration of a bus. Acceleration is equal to final velocity minus initial velocity by time. So which is minus 20 by 5 is equal to minus 4 kilometer per hour. So what is the right choice? Yes, of course, that is B. Clear? Next type of question. A train starting from a railway station and moving with a uniform acceleration attains a speed 40 km per hour in 10 minutes. Find the acceleration. A train starts from a railway station. Whenever it is starting, that initial velocity u is equal to 0, which attains the speed 40 km per hour. That is the final velocity. And how many minutes? 10 minutes. 10 minutes they give. We need to convert into hours because options are in hours, right? Now, what is acceleration? Change of velocity by time. 10 minutes, how many hours? 10 by 60 hours because 1 hour, 60 minutes. 10 minutes, 10 by 60 hours, which is 1 by 6 hours. Now, final velocity 40 minus 0 by 1 by 6, which is 240 kilometer per hour square is the acceleration. Hope you got it. Yes. Yes, right? Now, let's end with this motion. Hope you understood distance, displacement, velocity, acceleration, and the difference between speed and velocity. Yes, there are some numericals of average speed and average velocity. We can meet in the next class. Bye for the day.